probability distribution is a function that describes how likely you will obtain the different possible values of the random variable. In other words, it's the probability of the different possible values for the random variable. Similar to random variables, probability distribution also has two types, discrete and continuous. A discrete probability distribution is a function that is created for an event that has countable outcomes, and each outcome is represented by a bar of data in a bar graph. Each bar of data represents the probability of each outcome. The sum of the probability of each outcome in the event will always be equal to 1. A continuous probability distribution is a function that is created for an event that has an infinite number of outcomes. Since the outcomes are infinite, a sum over such a set of numbers is not possible because the outcomes are uncountable. Instead of finding the sum of the possible probabilities, we find the area under the curve using integral calculus. This type of calculation is beyond what is required for the praxis test, so it will not be covered here. Here's an example. The random variable t is defined as the number of tails after a fair coin is flipped 4 times. Find the probability distribution for t. Draw a graph of the probability distribution. Let's start by writing out the possible outcomes. We have heads, 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 tails, and so on. Next, determine the probability of each type of outcome. Let's start with the probability of t equals 0, or the probability that no tails are obtained. That only happens when the outcome is heads, 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 heads. Therefore, the probability of t equal to 0 is 1/16. The probability of t equaling 1, or the probability of flipping only one tail, happens in 4 of the 16 outcomes. So the probability of t equals 1 is 4/16, which is 1/4. The probability of t equals 2, or the probability of flipping 2 tails, happens in 6 of the 16 outcomes, so that probability is 3/8. The probability of t equals 3, or the probability of flipping 3 tails, happens in 4 of the 16 outcomes, so that probability is 1/4. Probability of t equals 4, or the probability of flipping 4 tails, happens in 1 of the 16 outcomes, so that probability is 1/16. Now let's draw a graph of the probability distribution. So the probability of t equals 0, which is right here, is 1/16. So we can fill this in here. The probability of t equals 1 is 1/4, and that's this line there. For t equals 2, it's 3/8, which is right there. For t equals 3, it's 1/4 again. And for 4, it is 1/16. And there you have it. Here's another example. Abad is running a restaurant and wants to learn more about his customers' choices. Abad collects data on 8 tables of 3 people and marks down if each customer ordered an appetizer or not. The data that was collected is given in the table to the left. Y represents yes, they ordered an appetizer, and N represents no, they did not order an appetizer. Draw a graph of the probability distribution for the number of appetizers served at the table. Alright, so how many times did nobody order an appetizer? So that's right here. N, N, N. And right here. So that happened 2 of the 8 times. So 2/8 is 1/4, which is 0.25. So you can see that at 0, we have 0.25. Where did they order 1 appetizer at the table? Well, that would be 1Y, which is Y, Y, and just those 2. So 2/8 gives us another 0.25. Which tables ordered 2 appetizers? That's right here, here, and here. So that's 3/8, which gives us this bar right here. And then finally, 3 appetizers would be right there, just one time, giving us 0.125 bar right there.